next thing that I would like to do is I would like to join. Okay, I like to join point A to point C, and then from point C to point B. Okay, point. Okay. So what you realize is at point C, the angle is always 90 degrees. Okay, it's always 90. If you don't believe me, or if you have doubt, I'm gonna pick another point. Okay, I'm gonna pick another point over here, and this point is my point D. Right? I deliberately picked that point because when I pick the point is what a coincidence, right? So from A, you can see my background line, right? My paper line, right? So A to D and D to B, this is also 90 degrees. Okay, so this is also 90 degrees. Okay, right. So I want us to focus for now our triangle ACB. Okay, so from point C, right? From point C, I'm going to draw to the center of the circle. Okay, I'm going to draw to the center of the circle. Okay, so from point C, I'll draw to the center of our circle. Okay, so I'm going to call this our angle alpha, and this is also our angle alpha. Okay, and we know that this is the radius. This is also the radius. So basically, we have an isosceles triangle. So the angle over here is 180 minus 2 alpha. This angle over here is 2 alpha. Okay, so I'm going to measure with my protractor. Okay, I'm going to measure my protractor on the screen. So the angle is about 24 degrees. So for this case, I've drawn the alpha over here is about 24 degrees. And this is measured. Okay, the 2 alpha will be equal to 48 degrees. Okay, so the 2 alpha which I've drawn, I'm measuring now, is it 48? I'm eyeballing this now. Yeah, it's about 48 degrees. Okay, so that is what we mean by the rules of the circle. Okay, so before we do anything with the Mohr circle, we have to understand the rules of the circle first. Okay, so that is what I'm doing this for. Okay, next we are going to do an example. Okay, so this example that we're going to do is going to combine both normal stress and shearing stress, and I'll explain to you later on when we have completed this example. Okay, why this is critical when we design any structure on using Mohr circle. So regardless of what structure you are analyzing, okay, at the end of the day, you have to come back to Mohr circle to determine a specific stress value. Okay, so that's why we are learning this for. Right. So let's look at an example. Okay, so let's look. So example number 1. Okay, so we're going to draw an element first. So this week we are going to draw an element. Okay. Next week we're going to draw a structure, and from the structure, how to determine the stresses of that element, which is called combined loading. Okay, so for this week, the element and the stresses are all given. Okay, so we have our transformation. Right, so this is our x and this is our y. So over here we have a normal stress at 30 megapascal. So you can see that that is in tension. Then we have another stress down here. this is at 40 megapascal. And then we have a positive shear configuration, right? This is equal to 15 megapascal. Okay. So once you see this, you can immediately write this down that, okay, so what we have is we have stress X is equal to positive 30 megapascal. Stress Y is equal to minus 40 megapascal. The shear XY is equal to shear YX is equal to positive 50 megapascal. And we know that in terms of shear, it means nothing, okay? The positive 15 means nothing because the shear, it all dependent on the element rotation, either going the clockwise direction or in the counterclockwise direction. Yes or no, right? So it does not really matter whether it's positive or negative shear. So what we're trying to determine down here, so we are going to find, okay, we are going to find the following, okay? We're going to find the average normal stress. Okay, and you have the impression that the average normal stress, as mentioned earlier, is known as the center of the circle. All right, so first thing, and then the next thing we're going to find is we're going to find the maximum. And I'm going to use this term, okay? I want you to get used to it. In plane, okay, shearing stress. Okay, now, what is in plane or out of plane? Okay, in 2D, you can't really see it. Okay, you only can see it in 3D. Okay, so once we go 3D Mohr circle, then I'll talk to you what is in plane and what is out of plane. Okay, so now bear with me. For 2D, we always call it in plane. Okay, there's no out of plane in 2D. Out of plane is the plane is coming into your face. In plane is on the surface now. Okay, then we are going to find the principal plane or principal stresses. Okay, we are also going to find the principal plane. And then we're going to construct and label, okay, construct and label the element orientate, okay, orientate in the principal plane or at the principal plane, not in. Okay, so we are going to draw Mohr circle now. Okay, we're going to solve this problem by using Mohr circle. Now, in our course, okay, we are not going to use any transformation equation. If you in the exam you use transformation equation, you get 0. We're going to solve this all by using Mohr circle, okay? Why? It's easier. Trust me, when I say it's easier, it's really easier. You can solve any problems and you can feel, okay, to me, it's not just by putting in numbers. I want to feel what this number actually means, okay? Because later on, we're going to relate this to our yield strength, okay? Right. So now we are going to construct Mohr circle. Okay, so we are going to construct vertical first, okay? So our normal stress, so that is our vertical. So this is our shearing stress in the clockwise direction. So it's 40, 30, 20, 10, 0, then minus 10, minus 20, minus 30, and then we have minus 40. Okay, so that is for our shearing stress. And then down here is the element rotate in an anti-clockwise direction. Okay, then we have our x-axis. Right, so this is our normal stress. So we have minus 10, minus 20, 30, 40, minus 50. Okay, 0, 10, 20, 30, 40, 50. And I want you to take note of this. The scale used on the x-axis, on the normal stress and the shearing stress has to be the same. If it's different, you want to get a circle, you get an oval. Okay, right. So you note that the scale are the same. So over here, we label this our point X. Over here, this is our point Y. Okay, so we have 30, our 30 line. Right, so this is our stress X line. And then we have our 40. That is our stress Y line. Okay, that is our stress Y line. And then our shear is 15 megapascal. So 15, remember I told you, right? The magnitude don't mean anything at all in shear. So you have to draw both positive 15 and then negative 15. Okay, let's focus on point X first. Okay. So we're going to focus on point X. Okay. So point X lie down on stress X axis that I've just highlighted in yellow. Right, is on the 30 megapascal line. So the 15 now, where this shear arrow I've just highlighted, it will cause the element to rotate in a what? Anti-clockwise direction if we pin the center. Okay, so if you put your finger at the center, imagine if the element can rotate, right? The 15 megapascal with the highlighted yellow in the shear will induce anti-clockwise rotation. So when that's the case, over here, right? So this is anti-clockwise, right? So when that's the case, point X is over here. Okay, that is your point X. And then if you look at your point Y, right? So if we go look at point Y, right? So we're going to look at point Y now, right? The one highlighted. And point Y will lie on your stress Y line. So we don't know, is it up above the normal stress line or below the normal stress line. Okay. So this over here, right, the 15 that I highlight in blue will cause the element to rotate in a clockwise direction, right? So that's the case. Clockwise is also down here now. So over here, this is your point Y, right? So from here, we can draw a straight line. And then immediately, we know at this point over here, this is our point what? Point naught. Okay. So point naught is our center of the circle, and point naught is also our stress average magnitude. Okay. So that is our point naught. Okay, I'm going to draw a straight line down. So from here, we can also immediately calculate what is our center of the circle, right? So we can immediately calculate center of circle. Right? As what we said before, center of circle is known as stress average. So this is equal to stress X. So stress X is 30, right? Plus by what? Minus 40, Remember I told you what? The stresses are all vectors. So don't forget the sign. Okay, that's why you have to include the minus 48. So this is equal to minus